Hello folks, we are back at the exercise 14.5, but this is the last part 3 video where we have to, they give us certain statements and we have to analyze whether it is true or false, and then on the basis of that you have to also reason, right? So that's quite interesting. So let's take the first subpart. Each radius of a circle is a chord of a circle. How can a radius become chord? Then why should we ever call radius two names? Yeah, if it's the same thing, why should we have two names? We can have one single name, right? No, it's not. It's a false statement. And why it's a false statement? Maybe I can represent with this diagram. Radius is something like this, and chord is something like this. How can radius be equal to a chord, right? So radius is connecting the center and a point on the circle, but chord is connecting 2 points of a circle, so they are not the same, right? That's a each radius of a circle is false because radius joins the center to a point on the circle. But chord joins 2 points of a circle. So that's a basic difference. Yeah. So this is the radius and this is the chord. That's it. So that's a basic difference. So that was our reason number 1. Then we go to reason number 2. We'll require some place, so that's why we'll write the numbers once again. The center of a circle bisects a chord of a circle. How come? How is it possible? Center will lie somewhere, chord will lie somewhere. How can it ever bisect? Only in cases where the chord is a diameter, probably it can do, but not otherwise. Again, that's false. Second statement is false again. Why? Because you have a chord somewhere here, right? And you have a center somewhere here. So how is the center going to bisect the chord? Yeah, there is no possible way. Only thing when it's a diameter or something like that, when you have a diameter, that can happen. That time center can bisect, but not otherwise, right? So we can say that it's a false statement. Why? Because center lies far apart from the chord. So it is not possible to bisect. The chord, right? Only in cases of diameter it can do, but it cannot happen everywhere, right? Circle is a particular case of an ellipse. Very much, very true. Yes. Why it happens? That's a true statement. Third one finally is a true statement. So why it is like that? Because we had learned the ellipse equation. The ellipse is represented by the equation x squared by a squared plus y squared by b squared equal to 1. This is the equation of ellipse. In cases where you will have a equal to b, for example, then it will become a circle. So it will be like x squared by a squared plus y squared by a squared equal to 1. Denominators are same, so it can go on the other side. X squared plus y squared whole by a squared equal to 1. So x squared plus y squared equal to a squared. And this will become a circle. So the ellipse is a particular case of a circle. It is true, right? By this by this kind of working. Yeah. Fourth reason we will write here. What is the fourth one? X and y is such that they are integers, but they are such that if x is greater than y, then minus x definitely. Yes, true. Why? Because it's a property of the inequality, that if you have x greater than y, then what I will do? Multiply or divide by minus 1. Both you can do. Either you multiply or you divide by minus 1. So multiply or divide, both as I said will do. Multiply by minus 1 on both sides. So what will happen? It's a rule that the moment you multiply or divide, then you have to change the sign. So it will become minus x less than minus y. So you get minus x less than minus y. That's a straightforward rule that comes from the property of inequality. right? That's why this happens, and that's a true statement. Okay. Root 11 is rational, no, it's irrational. Yeah, it's false. Now, why it is false? See, for irrational number, we had learned 3 possibilities in our 9th standard. First is that, what is an irrational number? An irrational number is that number which is square root of a prime number, or it is that number which has got a non-terminating, non-recurring decimal representations. These are the two straightforward logic from where we will pick up whether a number is a irrational number or not. These are the two identification points for finding out whether a number is irrational or not. So here, since we don't have the decimal, but we have a square root of a prime number, that is enough for us to find out that it's an irrational number. So by no way it is rational, it is irrational. So we will write it, we have written it's false. And why? Because root 11 is the square root of prime number 11, which has to be irrational. That's it. Right, so that's how we get across with it. It's quite an interesting thing. No? All our good old days, whatever we had studied, we brushed up with the concept, we got all those clear with us, and we've got all the reasons. This is how it's happening. That's about it. And we finish our exercise 14.5. I suppose we also finish the exercise. I think we'll be right away starting with miscellaneous. Next day we'll be meeting, next video we'll be meeting with our miscellaneous exercise. Thank you.